Hello, today we are going to discuss about radio wave propagation. What is radio wave propagation? Radio propagation is the way radio waves travel or propagate when they are transmitted from one point to another and affected by the medium in which they travel, and in particular, the way they propagate around the earth in various parts of the atmosphere. Radio signals can travel over vast distances. However, radio signals are affected by the medium in which they travel, and this can affect the radio propagation or RF propagation and the distances over which the signals can propagate. Some radio signals can travel or propagate around the globe, whereas other radio signals may only propagate over much shorter distances. Factors affecting radio wave propagation. There are many factors that affect the way in which radio signals or radio waves propagate. These are determined by the medium through which the radio waves travel and the various objects that may appear in the path. The properties of the path by which the radio signals will propagate governs the level and quality of the received signal. Reflection, refraction, and diffraction may occur. The resultant radio signal may also be a combination of several signals that have traveled by different paths. These may add together or subtract from one another. And in addition to this, the signals traveling via different paths may be delayed, causing distorting of the resultant signal. It is therefore very important to know the likely radio propagation characteristics that are likely to prevail. The distance over which radio signals may propagate varies considerably. For some radio communications applications, only a short range may be needed. For example, a Wi-Fi link may only need to be established over a distance of a few meters. On the other hand, a shortwave broadcast station or a satellite link would need the radio waves to travel over much greater distances. Even for these last two examples of the shortwave broadcast station and the satellite link, the radio propagation characteristics would be completely different, the signals reaching their final destinations having been affected in very different ways by the media through which the signals have traveled. Now, what are the methods of propagation of a radio wave? In radio communication systems, we use wireless electromagnetic waves as the channel. The antennas of different specifications can be used for these purposes. The mode of propagation of electromagnetic waves in the atmosphere and in free space may be divided into three categories. Radio waves can propagate from transmitter to receiver through ground wave propagation, sky wave propagation, and third, line of sight propagation. In ELF, which is extremely low frequency, and VLF, very low frequency bands, the Earth and the ionosphere act as a waveguide for electromagnetic wave propagation. In these frequency ranges, communication signals practically propagate around the world. The channel bandwidths are small, therefore the information is transmitted through these channels has slow speed and confined to digital transmission. Now, a first one, ground wave propagation. Ground wave propagation of the wave follows the contour of the earth. Such a wave is called a direct wave. The wave sometimes bends due to the earth's magnetic field and gets reflected to the receiver. Such a wave can be termed as a reflected wave. The following figure depicts ground wave. The wave then propagates through the Earth's atmosphere is known as a ground wave. The direct wave and reflected wave together contribute the signal at the receiver. When the wave finally reaches the receiver, the lags are cancelled out. In addition, the signal is filtered to avoid distortion and amplified for clear output. Ground wave exists only for vertical polarization produced by vertical antennas. when the transmitting and receiving antennas are close to the surface of the Earth. The transmitted radiation induces currents in the Earth, and the waves travel over the Earth's surface, being attenuated according to the energy absorbed by the conducting Earth. The reason that horizontal antennas are not effective for ground wave propagation is that the horizontal electric field that they create is short-circuited by the Earth. Ground wave propagation is dominant only at relatively low frequencies, up to a few millihertz only. Sky wave propagation. Sky wave propagation is preferred when the wave has to travel a longer distance. Here the wave is projected onto the sky and it is again reflected back to the Earth. The sky wave propagation is well depicted in the above picture. Here the waves are shown to be transmitted from one place and where it is received by many receivers. Hence it is an example of broadcasting. The waves which are transmitted from the transmitter antenna are reflected from the ionosphere. The ionosphere, it consists of several layers of charged particles ranging in altitude from 30 to 250 miles above the surface of the Earth. Such travel of the wave from the transmitter to the ionosphere and from there to the receiver on Earth is known as sky wave propagation. The ionosphere is the ionized layer around the Earth's atmosphere, which is suitable for sky wave propagation. Sky wave propagation is dependent on reflection from the ionosphere, a region of rarefied air high above the Earth's surface that is ionized by sunlight, primarily ultraviolet radiation. The ionosphere is responsible for long-distance communication in the high-frequency bands between 3 and 30 millihertz. It is very dependent on time of the day, season, longitude of the Earth, and multi-year cyclic production of sunspots on the Sun. It makes possible long-range communication using very low-power transmitters. Most short-range communication applications that we deal with in this chapter use VHF, UHF and microwave bands, generally above 40 megahertz. There are times when ionospheric reflection occurs at the low end of this range, and then sky wave propagation can be responsible for interference from signals originating hundreds of kilometers away. However, in general, sky wave propagation does not affect the short-range radio applications that we are interested in. Finally, line of sight propagation. The most important propagation mechanism for short-range communication on the very high frequency and ultra-high frequency bands is that which occurs in an open field, where the received signal is a vector sum of a direct line of sight signal and a signal from the same source that is reflected off the Earth. The range of line of sight signals where there are no reflections from the Earth or ionosphere is a function of the dispersion of the waves from the transmitter antenna. In this free space case, the signal strength decreases in inverse proportion to the distance away from the transmitter antenna. According to the modes of propagation, this line of sight propagation is the one which we would have commonly noticed and used. In the line of sight communication, as the name implies, the wave travels a minimum distance of sight, which means it travels to the distance up to which a naked eye can see. Then we need to employ an amplifier cum transmitter here to amplify the signal and transmit again. The line of sight propagation will not be smooth if there occurs any obstacle in its transmission path. As the signal can travel only to lesser distances in this mode, the transmission is used for infrared or microwave transmissions. Thank you.